This week, without a single headline to warn us, the history of aviation may have just changed forever. While the world was distracted by the latest AI bots and smartphones, a startup called Hinetics quietly stepped out of the shadows to announce, "We have solved the impossible." They unveiled a prototype for a new electric machine. This isn't just a minor upgrade, it is a massive leap forward. A motor so compact and lightweight, yet powerful enough to lift a commercial passenger plane off the ground. We aren't talking about a new battery or a magic fuel. We are talking about reinventing the motor itself in a way that makes today's technology look like Stone Age relics. How did they do it? And how did they manage to essentially freeze physics inside a small box? Let's find out. The weight problem. Let's cut straight to the core of the issue. The eternal enemy of electric flight has always been weight. Traditional electric motors, built from heavy copper and iron, are simply too dense. If you build one powerful enough to lift a plane, it becomes too heavy to fly. It's a paradox. But Hinetics just flipped the script. They have engineered a machine that achieves a power density of 13 kilowatts per kilogram. Now, that might just sound like a number to you, so let me put it in perspective. The best electric motors currently used in EVs and experimental aircraft struggle to hit 3 to 5 kilowatts per kilogram. Hinetics hasn't just beaten the standard, they have effectively tripled it. The scale of power. Picture this, a device roughly the size of a carry-on suitcase. It weighs about as much as an average adult man. Yet this compact box pumps out 1 megawatt of power. Do you know what 1 megawatt looks like? That is over 1,300 mechanical horsepower. They have essentially packed the output of a small power station into a device you could almost wrap your arms around. Even NASA spent years trying to crack this code with the X-57 project, but this startup approached it from a completely different angle. The sci-fi tech, superconductivity. So, the million-dollar question: how do you extract that much power from such a tiny frame without the machine melting into slag? The answer lies in technology that was, until recently, pure science fiction: superconductivity. In a standard motor, when electricity flows through copper wire, it faces resistance. That resistance creates heat, which wastes energy. To fight that heat, you usually need heavy fans and massive cooling systems, which adds more dead weight. Hinetics, however, used specialized materials for their windings. When these materials are chilled to extreme temperatures, they lose all electrical resistance. It drops to zero. This means you can push massive amounts of current through a razor-thin wire, and it won't heat up, not even a degree. The engineering stroke of genius. But here is the real genius of their design. To work, this motor needs to be freezing cold. Did they strap a heavy refrigerator to the plane? No, they used the fuel itself as the coolant. The system is designed to run on liquid hydrogen. Liquid hydrogen is an excellent, clean fuel, but it is also incredibly cold, sitting at minus 253 degrees Celsius. In the Hinetics design, this freezing fuel flows into the heart of the motor first. It chills the superconducting wires, allowing the motor to run at peak efficiency. Once the hydrogen absorbs the heat from the motor, it expands into a gas and is sent off to generate electricity. It is a perfect, elegant loop. The fuel cools the engine heats the fuel for combustion. No wasted energy, no heavy cooling systems, just pure, optimized physics. This brings us to a fascinating crossroads. For decades, we've been told that true heavy-lift electric aviation was 50 years away. Hinetics just shortened that timeline drastically. This proves that the barrier wasn't physics, it was just an engineering puzzle waiting to be solved. But I want to turn this over to you. The technology is brilliant, but it relies heavily on liquid hydrogen infrastructure. Do you think this is the silver bullet the aviation industry has been waiting for? Or do you think solid-state batteries will eventually win the race? Let me know your thoughts in the comments below. I read them all. If you found this deep dive valuable, please hit that like button. It really helps the channel reach more people. And if you haven't already, subscribe and verify that notification bell so you don't miss the next breakthrough. Thanks for watching, and I'll see you in the next one.